All right, guys, we are working on a long block schedule worth of notes, but it's easy to understand the symmetry of things and transformations of things. Remember, transformations are that one-to-one relationship to work with rotations. And so we really need to make sure we understand what it is and make sure we're able to do so fairly easily. So here's the key thing we need to remember. Remember, a rotation is a transformation that turns a figure around a fixed point called the center of rotation. And a rotation of isometry, it's an isometry, so it preserves size and shape. And we also, so that means it's congruent to my original image and pre-image. So let's go through real quick and see which ones are a rotation or not. This one would be no. It's not a rotation, it is reflection. It's nice thing is we have these so we can refer to it. Now, yes, this next one is a rotation. It rotated about the point right there on the vertex. So yes, it rotates about the point on the corner vertex. Does that make sense? Just trying to give it a location. On the next one, is that a rotation, guys? Did it rotate around? No. It actually was a translation. No, it is a translation. And on the next one, yeah, it really looks like I'm either rotating it this direction, because we can go this way, or we could be going the other way, but it looks like I literally rotated it around the center of rotation here. So yes, rotated around one of the triangles vertices. So you can kind of see how that rotation kind of worked with this one. So it's not too bad when we have it. All right, so let's go to the next page. Let's talk about the things that you need to know. And we're going to get a little more of the direct definition, but we're going to apply it a little bit when you're doing this. A rotation is a transformation about a point. So we'll give a point, the center of rotation. So we make sure we know that. It's just that each point in this image are the same distance from point P, and all the angles from vertex P as formed by the point are congruent. So here's what we're talking about. If I want to rotate A to A prime, they have to be the same distance away, and they have to go the same distance that we're working with. So each of the points will go a different distance because they're further away or closer compared to their location. But then you have to be able to rotate it, the angle. And notice the way that I rotated it counterclockwise. Most rotations are counterclockwise if you say the angle is positive. If you say the angle is negative, it will rotate clockwise. So you kind of have to know the difference between the two. So here is how you do it if you're working with it in like kind of in the real world. We have to use our angle of rotation. By the way, that's about a 45-degree angle. So we're going to use that to be about. You should measure it. If I was being really particular, I'd measure what we're doing. But this is going to be my points. I'm going to go A, B, C. Now, I have to be able to get their rotation the same distance away. So notice this is just the angle that matters. And we're going to say that's like a 45-degree angle. But I need to go for A at the distance, see if I can get this on here, of that far away at a 45-degree angle. So I need to go about 45 degrees, and we're just going to say it's about here, halfway through. So make sure they're all about 45. And notice I got to go counterclockwise, so that's going to be my A prime. And let's put the A, let's go red with my A primes, make it a little bit easier. And then I'm going to go B. Now what's the distance for B? Now the distance from Q to B is right here. Okay, so it ends, so now I need to go about a 45-degree angle for it. It's about the same on the line there, so that's going to end up being B prime. And then C, its distance, we're going to get a different from the point measured. It's from here. And then I'm going to go and do a 45-degree angle with that. So it's going to be about right here when it rotates. Let me see if I got here. It'd be, yeah, about a 90-degree angle. We're going to go here. Now understand this isn't perfect, but it will give us an idea of its rotation. So if I just go ahead and put in the idea of this. You can see the new image. I'm going to connect the points. How it rotated in this direction. You could see the rotation all going 45 degrees. So it makes it a little more complicated, but it does work out pretty well when we're rotating it. Does that make sense? I hope so. It's a little bit easier to understand. So now remember, I love this. All rotations in this book are clockwise. So look, worksheet and notes. Worksheet and notes, because I actually used a different set of notes and worksheets on this. So we'll work with it. We'll go counterclockwise. All right, so then we're actually going to use some examples of this in just a moment.